Imagine this. You're standing outside, taking a deep, refreshing breath. Have you ever stopped to ponder where that air might have come from? Could it be that the oxygen you're inhaling was over the Atlantic Ocean just a few days ago, or floating through the rainforests of Brazil? The answer is quite astonishing. Yes, it could have. Air, much like the water in our oceans, is constantly on the move. This movement is driven by a variety of factors, and it results in what we call air currents. These currents can travel vast distances, crossing mountains, oceans, and yes, even countries. One of the primary drivers of these air currents is something known as the Coriolis effect, named after the French mathematician Gaspard Gustave de Coriolis, who first described it. The Coriolis effect is the apparent deflection of the path of an object moving in a rotating system. In simpler terms, it's the reason why things don't move in a straight line on rotating objects like our Earth. As Earth spins on its axis, everything on it wants to keep moving in a straight line. However, because the surface beneath them is constantly moving, they end up following a curved path instead. This applies to everything from the ocean currents to the air we breathe. Air wants to move in a straight line, but as Earth rotates, its path gets deflected. This deflection results in large-scale weather patterns and air currents that can travel across entire continents and oceans. These air currents are divided into three main types: Hadley cells, Ferrel cells, and polar cells. Each of these cells represents a section of Earth's atmosphere with distinct wind patterns. They play a crucial role in distributing heat and moisture around our planet, but that's a topic for another day. Factor influencing the movement of air is global atmospheric circulation. This is driven by the uneven heating of Earth by the sun. The equator receives more sunlight than the poles due to its direct alignment with the sun. This results in warmer temperatures at the equator and cooler temperatures at the pole. When air gets heated at the equator, it rises upwards and starts to flow towards the poles. This movement is part of what we call convection. Convection is essentially heat transfer through fluids, in this case, our atmosphere. As warm air rises at the equator, it leaves behind a low-pressure area. To fill this gap, cooler air from surrounding areas rushes in. This is what we feel as wind. Once this warm air reaches the poles and cools down, it sinks back towards ground level and starts flowing back towards the equator, completing what we call a convection cell. So to circle back to our original question, does air travel from one country to another? The answer is an unequivocal yes. Thanks to phenomena like the Coriolis effect and global atmospheric circulation, every breath you take could contain molecules of air from halfway across the world. Isn't that something to marvel at?